test, which is the ugliest and less well thought out piece of Viatra code I ever did. But it was done in a hurry. So my first idea was to check the name of the input file and output the preloaded XML configuration accordingly. It would get a flawless score for the basics 3 files, and I would have a better score than I have now. Okay, so then I decided to try to solve the problem instead, and that was a bad decision, because of course first rule is to convert a specification to a configuration node, and I started hunting for modes where they are mentioned. So some modes are mentioned in a when clause as the entry of the mode. Some modes are mentioned in a given clause in rules that are dependent on being in that node. And some modes are mentioned in a then part as a target node, and of course most nodes will occur in multiple different ways, but I'm not really sure if any mode is automatically guaranteed to appear in any of them, maybe in then, but I wasn't really sure about it, so basically I set up rules to collect all the mode names mentioned and then filter out the discrete different ones and then create modes for them. And then how to detect transitions between modes. So if there's a then branch with a specification what is the next node, and there's a given mode in the same rule, then I interpret it as a precedence edge. So far, no surprises. But what if there's no given? Then I should be able to move to that state from all possible states. And then what about this cycle of nodes, modes? So I really skip that case when there is no given. And it is also possible to transition to mode just when we enter the previous mode. It's actually permitted by the specification, so also had to handle the case when we just enter the mode and the when part detects it and moves to the next mode immediately. And after all this, I now assume that there's a cycle of ordering edges between the nodes. Actually, this could have been checked, but I didn't check this properly. And then, assuming that there's a cycle now, I select one arbitrary edge and delete it, except if there's no such ordering edge, because there's only one mode. And if I delete one edge of this cycle, then I have an ordering. So that was my strategy. And this is how this one part of it looks like in Viatra. So that's how I try to guess if there's a potential transition between two modes. So in one of the cases there's a test case, and the then part contains a switch to a target mode name, and the given part checks if we are in the source mode. And in the other case, it's always the same, but the when part is triggered on the entry to the source mode. And what's contained in these things, they are just very simple snippets from the model. So I created them by selecting some elements in the model and using copy-paste. They can be inserted as a graph pattern. Okay, and then the buttons. So for some buttons, their label is observed, and the mode is specified as given. For some other buttons, they are observed in all modes with no given clause. I actually didn't handle that one, didn't have the time to handle that one, so this is an incompleteness, but I'm not sure how many other people did this. Nobody? Okay. At least I thought of it.
Sorry, it's the button press, creating a button for a button press where there's no check?
No, actually the observe a button, meaning the second button has the label kaboom.
Yeah.
And given we are in mode something. And sometimes there's no given we are in mode, so it should be in all modes.
Yeah.
And actually I thought of that, but I didn't have the time to implement it. And and if the when button is often tied to a certain button, so the button also has to exist if it appears in a when part, And if there's a third button, reference for a certain mode, then there will also have to be a second button.
That's not true.
And how do you order an EMF collection that has a third element but no first and second?
Arbitrarily. Or, but
So that's only a string.
Sorry?
It's just a string.
Yeah, that's the string.
No, I think so if there's a first and a second button, then I think they have to appear in that EMF collection in the order first, second. Because otherwise the simulator won't place them on the right position, right?
The simulator places them according to the ordering in the EMF model, but you know this definition is contentious, and in fact on the project that I'm on, which is what I'm inflicting on all of you, this again is a contentious issue. Some people think that a third button just means positional. Some people think it means literally it's the third button in the collection. So.
But anyway, if you have just one button in the collection, so if you only want to have one button in the third position, it will be in the first position unless there are two other buttons before it. Maybe those two other buttons are inactive, but you have to enter them in the collection, otherwise the simulator will put it in the first position. So anyway, that's why I spent a lot of time on trying to solve the problem instead of trying to solve the specific input models, which of course should have been much easier by preloading the output models correspondingly, but I tried to solve the problem and then I wasted a lot of effort on it. So yeah, that's how I detect which buttons are actually needed, and then I just extract the known labels and assign no labels for those for which the labels are not known. So basically, a specific mode name in the specification needs a specific button place if it is reference, or for example, the first button is needed if the second button is needed. So that's it. And well, can I get some extra time because there was some discussion? So there's 2 minutes for questions, and I've used some of that already. Sorry. So. Yeah, that's how it works, and there's a rule which extracts if there's a second button and this is the next button, then this is the third button, and if the third button is needed and the second button is already there, then the right hand side of the GPU has just this next button relation, which puts in the third button. Because I have the same problem that Viatra is fundamentally unordered, so I have next edges to maintain the ordering. And finally, as the last step in the trivial part, putting in the action on button press and mode entry, which looks like as it is being the big part of the case study, but it's actually the last 20 minutes or so, because I have wasted all that much effort from anything else. And currently I've only done in the last 20 minutes the display string change and the next mode switch, so it was only enough for the first file. And probably given one more half hour or so, I could have tried to tackle the other ones, and it's also an incomplete solution because I didn't handle the cases where no mode is given. So I'm not sure how many people did that, but anyway. So thank you, that was it.
Could you please show the code that we can somehow measure conciseness?
Okay, it's not very concise. There's also some copy paste in there because I was really in a hurry. So it's almost 400 lines, so it's pretty big. Of course, these parts are generated automatically, but still. So basically, in the top, this is the map specification to a configuration. The left-hand side and right-hand side are trivial, and there's also an attached action which does all other stuff. Then create the mode names and create a mode for each. Then add ordering between the modes and delete one of them. Then make all the first buttons, make all the second buttons, make all the third buttons. Label the buttons. Add the mode switch actions and the display actions. And basically, there's a lot of patterns and there's a lot of composition of patterns, and then there are graph transformation rules like this. This is the one that finds mode names that do not have corresponding modes then, and in the right hand side it creates the mode and then also sets some attributes.
I think we really have to go on
Yeah,
with the
yes.
presentations. Okay, so